40-mile-per-hour wind. That's all it took to tear this bridge apart. It had opened 4 months earlier, hailed as one of the most advanced bridges on Earth. To understand why it fell, you have to go back to how it was built. In 1937, Washington State needed a bridge across the Tacoma Narrows Strait. State engineer Clark Eldridge proposed a solid design with deep 25-foot support girders. But that design was expensive, so officials brought in a more famous name. Leon Moisseiff, a celebrated engineer who'd helped design the Golden Gate Bridge. Moisseiff proposed something radically different, girders only 8 feet deep, not 25. Thinner, cheaper, sleeker. It would look like a ribbon stretched across the water. His theory said flexibility was fine, as long as the structure could bend and recover. Construction moved fast. By July 1940, the bridge was open to traffic. Almost immediately, drivers noticed something strange. The deck rippled under their tires. In light wind, the roadway would rise and fall in gentle rolling waves. Locals gave it a nickname almost right away, Galloping Gertie. Some drivers said crossing it felt like riding a boat over ocean swells. Here's the strange part. Engineers weren't alarmed. They'd expected some movement. Vertical bouncing, they believed, was uncomfortable but structurally harmless. So a plan was drawn up to add cables and dampers to calm the motion. But before that fix could even begin, the wind picked up on one November morning. The date was November 7, 1940. The wind, a steady 42 miles per hour. Not a storm, not a hurricane, just an ordinary blustery Pacific Northwest morning. A newspaper editor named Leonard Coatsworth started driving across, his daughter's dog Tubby in the back seat. At first, the deck moved the way it always did. Then something changed. The bridge began to twist, not just bounce, one side rising as the other dropped. Coatsworth lost control of his car and abandoned it, crawling on his hands and knees to safety. He couldn't get the terrified dog out. Tubby bit anyone who reached for him. The twisting kept escalating. Witnesses on shore said the deck was tilting nearly 45 degrees. A local camera shop owner, Barney Elliott, grabbed his equipment and started filming. That decision would make this one of the most studied disasters in engineering history. At 11:02 a.m., the stiffening girders finally buckled under the twisting stress. The main span, nearly 2,800 feet of steel and concrete, dropped into Puget Sound. Remarkably, no person died that day. Tubby the dog was the only casualty. But the real question was only beginning. What actually caused this? Washington State assembled a board of top engineers to find the answer. Among them, Othmar Ammann, designer of the George Washington Bridge, and physicist Theodore von Karman. First, they ruled out the obvious suspects. The steel wasn't defective, the concrete wasn't weak. The construction had followed the plans exactly. Nothing had been built wrong. So, if nothing was broken, why did it break? The answer came down to those shallow 8-foot girders and the shape of the deck. A solid, flat plate girder blocks wind completely, forcing it to flow around the edges. That deflected air peels off in swirling pockets called vortices on alternating sides of the deck. Each vortex gives the deck a tiny push, first one way, then the other. Normally those pushes are too small to matter, but something else was happening too. As the deck twisted, it changed the angle facing the wind, which changed the force hitting it. That new force twisted the deck even further, which changed the angle again. Engineers call this Aeroelastic Flutter, a feedback loop where wind and motion feed each other. Each cycle of twisting fed more energy into the bridge than the previous one released. There was nothing in the shallow girder designed to absorb or interrupt that growing energy. It wasn't a strength problem, it was a shape problem, one no one had tested for. When Tacoma rebuilt its bridge in 1950, engineers threw out the solid girder entirely.